I'd like to talk to you and explain to you about one of the interesting signals that happen in the Great Lakes of Michigan. We have a signal which is called the thermal bar. In the springtime, the nearshore area of the lakes warm faster than the offshore areas. This creates a thermal bar which reduces mixing. If this is the thermal bar with the warmer water here and the cold water on this side, it prevents mixing. Now this mixing is important because in the spring we have the spring melt-off, and the question is, does that thermal bar establish itself in time to capture these nutrients? When we look at how close these two events happen, we see that sometimes it's able to capture those nutrients and sometimes it's not. So our idea is that if it is able to capture those nutrients, we will be able to see phytoplankton blooms in the near shore, and if it's not, we will not see those phytoplankton blooms. So in 2011, we went out on the Agassiz and we sampled Lake Superior, and we compared it with data from 1999, and we see that if the spring runoff, which is in red, happening in 1999, we see that the thermal bar happens and captures the tail end of the spring runoff. In 2011, the spring runoff happens here and the thermal bar establishes really late and is not able to capture those nutrients. So when we compare that and look at what happens with the spring phytoplankton bloom, we see that for 1999, a huge spring phytoplankton bloom happened in the near shore. When we compare that to the data of 2011, we see that May 19th, the water is still cold, no response from phytoplankton. May 29th, still no response. We're already in June 16th, and we finally see that the thermal bar established itself, but we still have no response in the chlorophyll because all the nutrients have already washed out into the big lake. And so this is important knowledge that we need to incorporate in predictive models for Lake Superior if we want to capture these events and be able to predict model perturbations, for instance invasive species like the Asian carp, or climate change, increased temperature. If we cannot model these things and don't understand them, we cannot build good models. Thank you.